Yeah. So we are going to study today's basic system properties. So what is the meaning of a system? So we understood what is signal. So there is a kind of a system also. Okay. So like you have a input x of t, and it's going to a particular system. And what this system do? It give you output y of t. Okay, output. So you had applied input to the system, and that system will process something and it will give you output. It will generate output. Like you have y of 1. Okay, output y of t. So the input was, this is our output, and the input could be x of t, x of t minus 1, x of t plus 1. So what is the meaning of x of t? You are putting x of 1. What is the meaning of x of t minus 1? Put 1, because we are putting t is equals to 1. Okay, so t is equals to 1. If you will put, what you will get? X of 0, and it will generate x of 2. Okay, so what is the meaning of this? This is your present value. Present value. Okay, what about this? Past, because we are applying 1, but it's giving 0, and this is future. Okay, so there on the basis of present value, past value, and future value, the system has been designed in a static and dynamic. So write the first topic, that is static and dynamic system. Static slash dynamic system. So what is the meaning of a static system? Static system. What is the meaning of a static system? If output of system, if output of system depends only on present value, only on present values of input, then system is called static. Okay, it is also known as memoryless system. It is also known as it is also known as memoryless system. Okay. Now there is another system, that is dynamic system. Dynamic system. So what could be the meaning of a dynamic system? If output of system depends on past or future value of input at any instant of time, then system is called as dynamic. System. Okay, it is also known as system with memory. Okay, it is also known as system with memory. It is also known as system with memory. Okay. So for example, I will give you like question number 1. You have to say static or dynamic. Y of t is equals to x of t plus x of t minus 1. So this is static or dynamic because my output depends on this is my dynamic. So past value is coming dynamic. Memory is there. Okay. So this is the present value. This is your present value. But this is, what about this? This is your past value. So this y of t is depends on present plus past. So the system is dynamic. Okay. Now the question number 2.
Why it is not static?
Because in this, see, a past value is coming. Okay. If any means in any summations, if you are getting the past values, like you can put y of 1, what you will get? X of 0 plus x of minus 1. So minus 1 is what? You are giving 1, but it's taking the past input. So past, this is your past input. It is present input. This will be x of 1 only. So this is the present input, but it's depend on the past also. So that's why it's dynamic. Okay. Now y of t is equals to x square of t plus x of t. So what will be this? Static or dynamic? Tell me, static or dynamic? What it will come?
Dynamic, sir.
No, it's a static. Put the one value any, means it's depending on t only, na? There is a no plus minus. So x of 1 whole square and x of 1 whole square and y of 1 means any time whatever the value you will put, you will get the present. This x of 1 is a present value. Okay. So this is also present. This is also present. So it is static. Okay. Now you have the second question. You have to tell. Question number 3. Y of t is equals to x of 2t. Static or dynamic?
Dynamic.
Yeah, dynamic. Put t is equals to 1, y of 1, x of 2. So it's depending upon the future value. So it's dynamic. What is this? Y of t is equals to even x of t. So this is dynamic or static? You can say what will be this, static or dynamic? Even function of x of t. So even function of x of t can be represented as, we discussed in our previous lecture, even function can be described as x of t plus x of minus t divided by 2. So if you will put the one value, x of 1 plus x of minus 1 is coming by 2. So this is what? This is past value and this is present value. So what will be this? Dynamic. So you need to know. That's why I told you even value and odd function. Even function is this, x of t plus x of minus t divided by 2, and odd was x of t minus x of minus t divided by 2. This was the odd. So even odd will be dynamic only. Okay. Now the second one is fifth question. So not is the second one, this is the fifth one. So fifth one is y of t real of x of t. Okay. So real signal is discussed in the conjugate and conjugate symmetry and anti-conjugate symmetry. So this is real signal will always be symmetry. And what is the formula of symmetricity? X of t plus x conjugate of t divided by 2. And the real x conjugate of t is x of t only. So this is always depending on our present value. So this will be static. We discuss these things. If you are forgetting, just go and revise your previous lectures and all. Question number 6. Always remember y of t integration minus infinite to t x of tau into d tau is dynamic. Integration and differentiation will always be dynamic. Okay. So like that, if you are putting t is equals to 0, x of 0, you will get minus infinite to 0 x of tau d tau. Okay. So this minus infinite represent your past value, and this 0 is your present value. So it is dynamic. And question number 7, y of t is equals to dx of t divided by dt. So this is your dynamic only, because dx of t divided by dt is your dx of t means differentiation means what? Differentiation means calculation of slope. And for calculations of slope, we require past value. So it is dynamic. I guess you remember, if this is your slope, this is 0, it's moving like this is 2, this is 4, so we are requiring the past value. Okay, so this is your dynamic. Question number 8, y of t is equals to x function of cos t. What it will be, dynamic or static? It will be dynamic only. Cos t, put y of 0, t is equals to 0. So what you are getting, cos 0 is 1, so x of 1 you are getting. At t is equals to 0, this value will become 1, so it is giving you future value, so it is dynamic. Now you understood. So do this question number 9. Y of t is equals to x of t plus 2 convolution of delta t plus 4 convolution of delta t minus 6. So what the result will come? So convolution of, so x of t plus 2 convolution of delta property, we know that all the things will be shifted here. So t will be, we can write t minus 6 plus 4. Okay, instead of this we are replacing to here. So and for this also we will do the same thing, x of t minus 6 plus 4 plus 2. So what you are getting, 6 minus 6. So x of t you are getting. So what is this? This is static.
Static.
Yes, it's static. It's not dynamic. But here it seems to be like static, but in the GATE exam the answer was dynamic. Here it seems to be like y of t is equals to x of t, but the answer was dynamic. Why so? We have to see the previous part only. So write one conclusion from here. There is a one conclusion. Okay, everyone get confused in this. So you have to remember this conclusion. if input output relationship involves time shifting time shifting time scaling time scaling differentiation integration system will always be system will be dynamic only dynamic only. So here our input means in this segment you see that the time shifting is there. So by calculating this you are getting x of t, but there is a time shifting. Okay, so from that this conclusions always remember this thing. So this was the story of dynamic system, static and dynamic system. The next system is causal system. Okay. Yeah, causal and non-causal. So this is very important. Causal and non-causal system. So what is the meaning of a causal system and non-causal system? Any idea? Causal system? Any idea for causal system? Write it down. If output of system is independent of future value of input, then system is called as causal system. Okay, means it may have present value or past value, but future value, it should not have the future value. For example, okay, for example you can take example 1, y of t is equals to x of t, means present value, it's depending on the present value. Second example, y of t is equals to x of t minus 1, so it's depending upon the past value, so but no future value. Third example, y of t is equals to x of t plus x of t minus 1, so it's depending upon the present value and past value also, so also it is causal system. But if y of t is equals to x of t plus 1 plus x of t, so future value is coming, so this is not a causal system. Okay, this is not a causal system, non-causal system, we say it's a non-causal system. So what is the conclusion? Causal system can means your output can be depends on present input, or output can be depend on past input. Okay, and both present and past. Now non causal system. So if output of system depends on future values input at any point of time, at any instant, at any instant of time, at any instant of time, then system will be non causal. Okay, for example you can write like this: y of t is equals to x of t plus 1. Second example, y of t is equals to x of t plus x of t plus 1. Okay, third example, y of t is equals to x of t minus 1, x of t plus 1. So from why the system is becoming causal? From this t plus 1, this future value, this future value, this future value. So this is your present value, this is your past value. But if you are getting the future value in the signal, that means the system is non-causal system. Non-causal system. Always remember. If any future value is coming in a part of the part of your output, then the system will be non-causal system, right? And there is a one another thing, anti-causal. Anti-causal. Guess it. What will be the property of this anti-causal? What can be the property of this? A non-causal system in which output depends only on future value, only on future value, means every anti-causal system is non-causal system. Okay, every non-causal system cannot be anti-causal system. This is your non-causal system, but here present a past value is there, so this is not anti-causal system. But this y of t x of t plus only future value is coming, so this can be anti-causal system also. So a non-causal system in which output depends only on future value. For example, y of t is equals to x of t plus 1. Okay, so all anti-causal systems are, what you understood from this, all anti-causal systems are non-causal. Okay, all anti-causal systems are non-causal, but converse of this is not true. But converse of this is not true. Converse of this is not true. Practical systems are example of causal system. Okay, practical system means all the system which are practically used. Practical systems are example of causal system. Okay, this is one thing. So I told you what is causal, which depends on present and past. Okay, so this future is impractical. Okay, all the practical systems are actually a causal system only. So like example I can give you, example of practical systems are mic, electricity. These all are practical systems. So what is that? Mic, electricity, all are causal system. Okay, so this is the imaginary thing, means anti-causal and non-causal systems are imaginary thing, but practically we have causal system only, which only depends on present and past value. So check. The question is, you need to check whether it is causal system or anti-causal system or non-causal system. Y of t is equals to x of 2t. What is this? Causal, non-causal, anti-causal, what will be this? If you put t is equals to 1, what you are getting? Y of 1 is equals to x of 2. So it is the future value is coming. So if the future value is coming means what? Future value is coming means it is non-causal.
Causal. Non-causal.
Yeah, non-causal plus, yeah, we can say non-causal only. If this is not anti-causal, how it is not anti-causal? If you will put t is equals to minus 1, so y of minus 1 is equals to x of minus 2. So in this case is depending upon the past value. Okay, but for anti-causal always it should depends on the future value. Okay, it, so this is not anti-causal, it is non-causal only. Like, yeah, question 2. Question 2 is y of t is x of 2t when t is lesser than 0, and x of t minus 1 when t is greater than equal to 0. So this is your causal or anti-causal. So see, what is the meaning? If your t is lesser than 0, means if you are substituting t is equals to minus 1, so what you will get? Y of t is equals to x of 2t. So I put x, so this is true, means this will come when t is greater than or equal to 0. So what you will get? Y of 1 is equals to x of minus 1, because this is t is lesser than 0. So y of minus 1 is equals to x of minus 2. So this is depending upon, this is your input, and the output what you are putting, so output is depending upon the past value. Okay, now if t is greater than or equal to 0, assume I am taking y of 0, so which equation will come? This equation will come, x of t minus 1. So you have taken y is equals to 0, y of 0 is equals to x of 0 minus 1. So y of 0 is depending of x of minus 1. So the present input is 0, but you are getting the past. So always you are getting the past. So what does the meaning? It is your causal system. If means you have to check like this only. In any case, if you are if it is giving the past, if it's giving the future value, in any case put like 2, 3, 4, then it will be non-causal. So in this part it will never give the future value, it will always give the past value. You can check by putting t is equals to minus 1, minus 3, minus 4, anything, it's up to you. Now the question number 3. So this is your question number 3. Y of t is equals to minus pi to, yeah, so it's given x of, it's not given any function. They had given the limit like this, x of sine t, they had given some function is there. So this is anti-causal, non-causal, means it will be, always remember, integration is coming, that means it's contain the future value. Like I will give you, when you are putting t is equals to pi or minus pi, yeah, if you are taking t is equals to minus pi, So y of minus pi, integration limit t is equals to minus pi, sine of minus pi will be 0. So this is your future value. You have taken the past value, but in this you are getting the future value. So this means non-causal. Okay. Question number 4. Y of t is equals to conjugate symmetry x of t. So you need to still and you know that conjugate symmetry formula, x of t plus x conjugate of t divided by 2. So when you will put t is equals to minus 1. So y of minus 1 if you are putting, so what you are getting, x of minus 1 plus x conjugate of minus 1 divided by 2. Okay. So this is minus 1. This is your minus 1 you are putting. Okay. Yeah. So what? So if you will put x conjugate t is equals to minus 1, if you will put t is equals to minus 1, so x conjugate of minus 1 is, x conjugate of minus 1 will give you x conjugate of 1 only. X of minus 1 plus x conjugate of 1 by 2, because x conjugate of t is equals to x conjugate of minus t. We discussed these things in conjugate symmetry. Just go through at the previous lectures. So x of minus 1 plus x conjugate of minus 1, it will give you, it's like a even number. Even means x of minus t, you are getting x of plus t only. So x minus 1 plus x conjugate of 1. So this is your future value. Future value is coming. So future value is coming. So this is non-causal. Now the fifth one is y of t cos x of t. So what will be this? Causal or non-causal? So cos function, I hope you remember, guys. Cos function can be written as ej x of t plus e power minus j x of t divided by 2. So if you will put y of 1, so this will also be 1, this will also be 1. So this will be causal only, because it's depending upon the present value. I hope you remember cos theta can be written as e power j theta plus e power minus j theta divided by 2. So like that I had written this e power j x of t plus e power minus j x of t. So if you will put any value, you will get, it's depend on the present value only. Present value. So this is causal system. And the next question is question 6. Y of t minus infinite to t x of tau into d tau. So at t is equals to 1, y of 1 minus infinite to 1 x of tau to d tau. Okay. So this minus infinite is your past value and this 1 represent your present value. So you are getting the combinations of past and present. No future value is coming. If it was t plus 1, then it was 2. So then future value will come. Okay. So this is your causal system only. Causal system only. And like I had given the second example, means like if you are having a y of t is equals to minus infinite to t plus 1 x of tau d tau. So this will be non-causal, because if you will put y of 1 is equals to minus infinite to 2 x of tau into d tau. So this is 1, but here we are getting 2. So this is your future value. So future value means it will be non-causal. What about this? Eighth example, y of t is equals to minus infinite to 2t x of tau into d tau. Causal or non-causal? Put y of 1 minus infinite to 2 x of tau into d tau. So this is your present value and this 2 is your future value. So this will be non-causal. This is past value. This is non-causal. So for non-causal type differentiation, output depends on the combination of present and future value of input. Okay, note it down. For non-causal type differentiation, output depends on combinations of present and future value of input. So if anyone is saying about the differentiation, so differentiation is non-causal because future value is coming. And for causal differentiation output, for non-causal type differentiation, output depends on the combination of a present and future value. For causal differentiation, output depends on the combination of present and past value. Okay, so if non-combinational system differentiation you are doing, so this value will depends on the present and future value. But if you are doing the causal system differentiation, then output will depends on combination of present and past value of input. So see, like there is a one example, it's a different question. Okay, y of t is equals to x of t convolution of u of t plus 1. Okay, so here time shifting means if you will put 1 here 1 will be there, here 2 will be there, so future value is coming. So this is non-causal, directly we can say. And I hope you remember the properties of convolution. X of t convoluted with u of t plus t naught is minus infinite to whatever the value here, so t plus t naught x of tau into d tau. This was the yesterday property. So if you will put anything, it will get added with t naught. So t naught is 1, so it's depending upon the future value, so it is non-causal. Write down the next example, y of e power t x of 2t. So this will be causal or non-causal? Causal or non-causal? If you are putting t is equals to 0, what you will get? Y of 1 and x of 0. So it's depending upon the past value, right? So it's depending upon the past value. So this is, but if you will put, okay, but if you will put t is equals to minus infinite, if you will put t is equals to minus infinite, what will happen? Y of e power minus infinite is 0.
0.
X of minus infinite will come. So this is your so
Present and past.
yeah, this is present and past. So past is minus infinite. Okay. Okay.
Same.
Yeah.
Present and past.
Yeah, great. But if I'll give you t is equals to infinite, if you will put, so what e power infinite is infinite only, and x of 2 into infinite is infinite only. So this is present and this is present only. So what can we say that this kind of a system is causal or non-causal? Causal.
Causal.
Causal. Yeah. And the last one is y of t is equals to x e power t. This will be causal or non-causal? If you will put t is equals to 0, so what will come? 1. So it's 0 is your present and 1 is your future.
Non-causal.
Non-causal. Clear? So this was the concept of causal system and non-causal system. I hope it's clear for you. Understood? Guys,
Yes.
understood? Okay. Now we are moving to linear and non-linear type system. Linear and non-linear systems. Okay, linear and non-linear system. So what is the linear system? What do you mean by the linear system? All linear system follow the principle of superposition, what we had seen in the network. So the same concept will come. All linear system follows the principle of superposition. Okay. So law of superposition is necessary and sufficient to prove the linearity of the system. Write it down. Law of superposition is necessary and sufficient to prove linearity of the system. So in network, what we had seen, so superposition should follow the two rule. One was law of additivity and the second was law of homogeneity. If these two rule will follow, then only the system will be following the superposition. If it is following the superposition, then the system is linear. Now what you will do to check the law of additivity? So for checking the law of additivity, what we do, so suppose this is your system, this is your same system, so you are giving the different input x1 of t, you are giving the different input x2 of t. Okay, so x1 of t, so y1 of t input you are generating and you are getting y2 of 2 input you are getting. Okay, so these two you will add it, summation. So what will be the result? Y1 of t plus y2 of t. Now what we are do, we are giving this to, first we'll sum this, we'll do the summation, then we will, so if we'll do the same, our input will be x1 of t plus x2 of t, then we'll pass from the system. Okay, and now if we are getting the y1 of t plus y2 of t, if we are getting like this, and if this and these are same, if this and these are same, that means your system is following the law of additivity. For example, you have y of t is equals to x of t plus 10. So suppose you are giving input x1 of t, so y1 of t will come x1 of t plus 10. Now suppose you are giving y2 of t input, so what you will get, x2 of t plus 10. Now suppose you are giving the input as x1 of t plus x2 of t, so what input you will get, what output you will get, y output, what you will get, so this is my input. Okay, so always input will be added with a constant, some constant 10, so x1 of t plus x2 of t, that is giving, yeah, with 10. Now if you will add this two equation, if you will add this two equations, so what you will get, x1 of t plus x2 of t plus 20 you are getting, so y1 of t plus y2 of t is equals to 20. So these equations and these equations are same? No, equation 1 is not equal to equation 2, so this is not following the law of additivity, this is not following the law of additivity. What is the meaning of this particular equations? Y of t input is always added with 10. So first we have taken the input as x1 of t. Okay, so we are getting the output y1 of t like this. So in this operation what we are doing, the system is doing input plus 10. So what the output we are getting, y1 of t is equals to input plus 10. Then the second input what we'll do, x2 plus 10. If we'll add both the output, so you will get x1 of t plus x2 of t plus 20. Now you are giving the input as x1 of t plus x2 of t. So this system will add with 10 only. So x1 of t plus x2 of t plus 10. So these and these are not same. So it is not following the law of additivity. I hope is this clear for you guys. Is this clear, guys? Prasanna, is this clear? Priyanka, is this clear?
Yes, sir.
Okay. Great. So this is your, then that means if
Sir,
it
can
is,
you scroll up the side one?
yeah,
So a little bit more.
lower or upper?
Okay, sir, continue.
So this is your, I hope you understood. So the system is not following the law of additivity. So what kind of a system is this? Non-linear. We can say non-linear. Now, so this was for the non-linearity, means we have checked the law of additivity. So there is the second law of homogeneity. Homogeneity. So how we'll check the homogeneity principle? So G-nity, okay, homogeneity. So you are applying x1 of t to a system, you are getting y of t to the system. You are multiplying these things with k, and if you are getting ky of t, okay, now you are previously multiplying this input, so with k, so input is kx of t, and then you are passing with the system. Then output is coming y dash of t, and if it is equals to ky of t, then it's following the law of homogeneity. What you are doing, this is your input. Your input is passed to the system, you are getting y1 of t. Then you are multiplying y1 of t with a scaling factor k. So if you are getting the output as a ky of t, fine. Now what you are doing, you are firstly multiplying your input with k, and then you are passing with the system, and then some output will be generated. And if this output is ky of t, if both are equal, then the system will be following the law of homogeneity. Example of this is, you have y of t is equals to x square of t. So first it will be passed through, means your input x1 of t is passed through the system. So what you will get, output what you will get, y of t you will get x1 square of t. Then this will be multiplied with k. Then what output you will get, k x1 square of t, k x1 square of t. Now what you are doing, first you are multiplying this thing, then you are passing with the system. Now your input is k x1 of t. So this whole is your input, and what is the system is doing, system is squaring the input. So if I'll pass with the system, so k x1 of t whole square will come. So what is the result, k square x1 of t. So these two are not same, so that means this is not following the law of homogeneity. The system will be non-linear, right? The system will be non-linear. In the same way you have to check. Now the question is coming. So question is y of t is equals to x cos of t. So what you will do, first do law of additivity. So law of additivity, what the law of additivity say, y1 of t is equals to x1 cos t. Okay, great. y2 of t is equals to x2 cos t. Okay, great. And this will be added. So y1 of t plus y2 of t, you are getting x1 cos t plus x2 cos t. Okay, great. Now what you will do, you will so this you will first you will take your input x1 of t plus x2 of t. This is your input. So what the system is doing, system is putting cos t in terms of t. Okay, system is putting cos t in terms of t. If it will passes with the system, so what the system will give me result, x1 cos t plus x2 cos t. So these twos are same only, means law of additivity pass. Okay, first is passed. Now you have to check for law of homogeneity. So for law of homogeneity, what you will do, put, so you are giving means x1 of t is passes with the system, you are getting y1 of t, then it is multiplying with k. Okay, then you will got what, k. So y1 of t is equals to x1 cos t you will get. Okay, then you will get k x1 cos t, right? Now you are firstly multiplying with the k factor. So k x1 of t is coming, and it is passing with the system. So this system is putting the value of a t as a cos t. So k x1 cos t will only come. So these two are equal only. So it's satisfying the law of homogeneity also. So both law of additivity passes, law of homogeneity also passes. So this system is linear system. Okay, see, this is my y of t and this is output I am getting, means I am putting x1 of t in some particular system. So what my system is doing, so system giving me some output, so which is putting t as a cos t. So x of cos t I am getting. Okay, so for checking the law of additivity, I have given one input x1 of t and another input x2 of t. So y1 of t I will get x1 cos t and y2 of t I will get x2 cos t. Both I had added. So x1 of cos t plus x2 of cos t I am getting. Now I am giving additions, means previous additions of the two input x1 of t plus x2 of t. So this system, the work of the system is putting t, replacing t as a cos t. So here 2t is there, t is here also, t is here also. That's why I will get cos x1 cos t plus x2 cos t. Okay, I will get like this. Okay, so these twos are equal. That means law of additivity are following. Same thing I did for the scaling factor. I putting x1 of t, the system will give me y1 of t, that is x1 cos t. That will be scaled by k. So I am getting the output k x1 of cos t. Now I am first what I am doing, I am scaling the input. Okay, so if I am doing the scaling, previously I am doing the scaling, so kx1 of t will come and then it will pass from the system, then it will give me the result kx1 cos t, right? And these two are equal, that means law of homogeneity pass. The system is linear. Both law of additivity and law of homogeneities are passed. I hope you got it. Okay. So now you have what sets of a question. So try to solve this. So this was the first question. This is the second question. Second question is y of t is equals to x log t. Okay, x log t. So you have to say about this is linear or not linear. Okay, linear or not linear. Okay, so check the additivity principle. Check the additivity principle. So what the system is doing? If you are putting x1 of t, so system is doing replacing t as a log t. So y1 of t you are getting x1 log t. Okay. Now if you will put a system to x2 of t, so you will get y2 of t as a x2 log t. When this both will be added together, so 1 of t x2 of t, and pass it with the system, so this same result will get y1 of t plus y2 of t will get, because it will simply replace the t function as a log t. So x1 log t plus x2 log t, and if you will add this, the same result will come. So that means law of additivity passes. For law of homogeneity, so you are passing x1 of t to a system, it is giving you a output y of t, that is x log t. You are now scaling this with k, so k x log t you will get. Now if you will first scale this with k, then if you will pass with the system, you will get the same answer, k x log t. So both are satisfying. That means the system is linear system. Linear system, right? Now what about this? Y of t is equals to x of tan inverse t. So this kind of a system will always be linear. Okay. If any function is there in x of t, if any functions of a t is there in x of t and nothing constant is added, no constant is there, then you can directly say this is the linear system. Whenever you will apply these things, you will get the linearity. What about this? Uh, Fifth one, y of t is equals to x of t square. So this is also a function, no constant is there, so this will be linear only. Linear only. You can check with this method. And you are getting the sixth question. Write the sixth question. Y of t is equals to x of t. So it's simply a linear only. Apply this and get the result. And if I'm giving you a seventh question like this, y of t is equals to even of x of t. So this will be x of t plus x of minus t divided by 2. So this is also a linear function. Linear only. Because if you check separate with this and separate with this, so this is only a function, no constant is added. So you will get the linear function only. So even x of t is a linear function only.
So fifth one is linear or non-linear?
It is linear. See, it is not t square x of t. If it was like that, then it will be a non-linear. But you are getting the function x of t square. See, you can check this by the principle. Y of t is equals to x of t square. So y1 of t will be x of x1 of t square only. Right? Right? And y2 of t
Yes, sir.
will be x2 of t square. When you will add these things, so y1 of t plus y2 of t, what you will get? x1 of t square plus x2 of t square, right? Now if you are giving the two different signal, x1 of t plus x2 of t to system, so system is what? It's replacing t as a t square. So you will get y of t output as a x1 of t square plus x2 of t square. So the system is what the system is doing. It's replacing t as a t square. Okay. So this result and these results are coming same. So that means system is following the law of additivity. Now simply check for the law of homogeneity. So what you will do, x1 of t, if it will be passed from the system, you will get x1 of t square. You scale it, you will get kx1 of t square. Now you scale the system, so it's passing with the system. So this is your input is kx1 of t. So you will again get kx1 of t square because the system is just replacing t as a t square. So these two are same. So that means this is following the law of homogeneity. So both are satisfying. That means this is linear. Okay. Understood? Understood or not?
Yeah.
Okay. the same manner, you have some system like y of t is equals to x log t divided by 2 plus x of 2t divided by 2. So this is because yeah, so this is linear, so overall will be linear only. So always remember, if you are having a log t sin t inside the x term, if you are having like this, and there is a no constant is added, so then the system will be linear only. You can check by the property what I taught you. So like you have a y of t is equals to sine sine t sine t into x of t. So this can be linear or non-linear. So this is one term, this is another term. So check it, y1 of t. What is the system? System is just multiplying our input with sine t. So this is the property of the system. So if I am putting system, if I am giving some input, so that input is multiplying with sine t. This is my system property. Okay, so if I am having a x1 of t, so what output I will get? x1 of t sine t. If I am having a x2 of t, what output I will get? x2 of t sine t. If I will add it, that means y1 of t output plus y2 of t output is equals to sine t comma x1 of t plus x2 of t. This thing's happening. Okay, now if I am adding these things and I am giving to the system, so my input is x1 of t plus x2 of t. So x1 of t plus x2 of t is my adding, it's my input, and it is get multiplied with sine t. So both are same, so it's following the law of additivity. So now check the law of scaling. If we'll check the law of scaling, so if you are passing x1 of t with system, it give me x1 of t into sine t. Now I had scale this with k factor, so k sine t into x1 of t is coming. Okay, fine. Now I will do first scaling, so means I am just multiplying with k, so k x1 of t is it's becoming my input, and then I am passing with the system, and the system property was whatever the input you are putting, it will just multiply it with sine t. So k x1 of t into sine t, both are coming same, and this means law of homogeneity passes and law of linearity passes, so superposition valid. That means my system is linear system. So this looks to be a very difficult, but it's not required, means you can do this kind of steps within a 30 seconds. Okay, now I will give you an example of linear or non-linear. Suppose you need to say about this will be linear or not linear. Okay, y of t is equals to t square x of t. Whether it will be linear or non-linear, what is the meaning? Means this is your input. So what is the system is doing? Whatever the input you will put, it will multiply it with t square to that input. This is the meaning of my system. So if I am putting x1 of t, so what output I will get? T square x1 of t, right? If I'll put x2 of t, what? This is my system. So t square x2 of t. So this both are added. So what I will get? T square x1 of t plus x2 of t. So and if I am adding this and I am giving this as an input, whole input x1 of t plus x2 of t, and giving to the system. So it's just multiplied with t square, and this is my input x1 of t plus x2 of t. Both are same. So law of additivity passes. And now check for homogeneity. So k, you will get output, you will get t square x1 of t, right? This is your system. Then you will scale with k. So k t square x1 of t. First you will do a scaling, then you will pass with the system. Then you will get what? So the input is k x1 of t. So it's just getting multiplied with t square. K x1 of t. So both are same. So this is linear. So law of homogeneity passes. So it is a linear system only. Right. So this kind of a system is linear only. So like y of t is equals to log t into x of t. So this is what my system is doing. System is getting multiplied with log t only, whatever the input. So like the same way this will give you linear result. Okay, check by yourself, it will give you the linear result. Last question is, you have y of t is equals to t square even function of x of t1. So this can be written as t square x1 of t plus x1 of minus t divided by 2. So you can, if you will check it by separately, you will get the linear result only. Linear result only you will get. Okay, so from what you understood from this overall things, note it down. Linearity of system is independent of coefficient used in system relationship. So whatever the coefficient you are using, this is your coefficient, this is your coefficient, okay, this is your coefficient. So whatever the coefficient you are using, it will give you the linear result only. Linear result only. So now check it for this. If the next question, check it for this. You have a y of t is equals to x of t minus 1 plus x of t plus 1. So whether what the input, what the system is doing, my system is first it is delaying the signal, then it is advancing the signal, and then it is adding. This is the property of the signal. This is the property of the system. Means what it's doing, it's first delaying the signal, then it's advancing the signal, then it's adding. So whatever the input you will get, so suppose I am giving the input x1 of t. So x1 of t, first it will delay the x1 of t. Okay, delay by 1. Then it will advance the x1 of t. So x1 of t plus 1, then it will add it together. So now my input is x2 of t. So it will delay the signal by minus 1. Then it will advance the signal by plus 1. So whatever the output I am getting, means if I'll add it, this is my y1 of t output. This is my y2 of t output. So y1 of t plus y2 of t. If you will put it, what the result you will get? x1 of t minus 1 plus x2 of t minus 1. So t minus 1. So x2 of t minus 1, then plus x1 of t plus 1, then plus x2 of t plus 1, if you'll add it. Now you are giving the input. My next input is x1 of t plus x2 of t. This is my input, and I am giving to this signal system. So what it will do? It will first delay the signal x1 of t minus 1 plus x2 of t minus 1. It's delay by 1. Then it will advance the signal x1 of t plus 1 plus x2 of t plus 1. So both are same. Yeah, both are same. Means law of additivity passed. Now what you will do? X1 of t, if you will put to the system, so we'll get x1 of t minus 1 plus x1 of t plus 1. So this will be scaled by k. So k, and this is I'm taking as a y1 of t. So it's happening, means k is multiplied with overall. So now if I am first I am scaling, then I am passing with the system. So what you will get? Same result you will get. K will be the constant. It will delay the signal by minus 1, then it will advance the signal by plus 1. So law of homogeneity also passes. So the system is, this kind of a system is linear system. Linear system. Now you will get a very difficult question like this, and by seeing this kind of a things, you can directly, you don't need to do anything. The question is like this: y of 2 root t x of t plus 2 x of t minus 1 plus t square x of t plus 2. So we have checked already if any coefficient, this is my coefficient only, is multiplied with the input, then the system is linear. Okay, I'm checking, this is my one signal. Okay, now I'm checking if also time shiftings happen. So time shifting is also happen, it will give me linearity only. This is my coefficient. So this is my coefficient, we already checked, and time shifting is also happening. So this will also give the linearity. So if this is giving me a linearity, if this one is giving me the linearity, if this one is giving me the linearity, so overall system will be linear only. You don't need to do all the step. Even if you do the step, you will get the answer. Okay. So whatever means, whatever the coefficients you are multiplying with x of t, so linearity means linearity of the system is independent of coefficient used. So whatever the coefficient you are using, log t, sin t, tan t, it is independent, even a constant term. So it is independent of that things. Okay. So you will get the linear. So you don't need to. But in exam, if you will see this kind of questions now directly, you will get nervous. So for that, you need to practice these things. A lot you practice, a lot you can do in the exam. So there is a one quotation: the more you shatter, the more you shine. So what is the meaning? Means the more you practice, you need to practice a lot. That's it. If you want to win this game, you need to practice. Okay. So we did it. So write it down, one note point. It's see, by seeing this na in exam, you will see, oh, root t is there, t minus 1 is there, t plus 2 is there. It's look like a non-linear, but it's linear. And the people who are not studying and going directly to the exam, they will definitely they will mark to the non-linear system, and then they will assume, means like, oh, I did one correct answer, but it's a trap. Write the note point: if output is summation of time shifted time shifted terms of input, then system will be system will be linear only. Okay, if output is the summation, so summation, this is summation, time shifted, so time shifting, and it is independent of the coefficient. I already told you it is independent of the coefficient. So there is a two things. If it is independent of the coefficient, so independent of the coefficient, so rule 1 is verified. And the summation, time shifted summation, if you are adding, then the system will be definitely linear. Okay, now I will give you one example of non-linearity. So see, y of t is equals to x of t plus sine t. Okay, then this kind of a system is non-linear system. How so? Check it. What is the meaning of the system here? What is the meaning of the system here? System is adding my input with sine t. So if I am applying x1 of t, so what the output I will get? x1 of t plus sine t. Right? Yeah. And if I am doing x2 of t system, then what will happen? x2 of t plus sine t. And if I'll add it, then I will get x1 of t plus x2 of t plus 2 sine t I will get. Right? 2 sine t I will get. Yeah. And now if I'll add this two, and if I'll pass with the system, so what I will get? x1 of t. So this is my input. Now the input is becoming x1 of t plus x2 of t. And it will, and what is the system is doing? Input plus sine t only. Sine t. So both are not same. These two are unequal. Because 2 is coming here. And here 1 is there. So it is non-linear. Right, it is non-linear. What's happened with this? Okay, just wait. Yeah, non-linear. So the same thing you can check it for different questions. The same thing you can check it for y of t is equals to x of t plus 10. So these things we had already checked. So it was non-linear. So what is the meaning? Meaning of this, note the point. The meaning of this is if any added or subtracted other than x of t or y of t, other than x of t or y of t. So this is not x of t, and the sine t was not x of t, which we have taken in this question. It is other than. Okay, other than x of t or y of t is available, then the system will be non-linear. Then the system will be non-linear. Right? Then your system will be non-linear. You have another example. Y of t is dx of t divided by dt. So this is linear or non-linear? It's linear. The system is linear. Okay, you can check it. So what is the meaning? What is the operation? So what you are doing? x1 of t is passes with the system, and system is what the system is doing? It's differentiating my input dx1 of t by dt. So if I'll apply the different signal x2 of t, so it will again differentiate it. So dx2 of t divided by dt, and both are getting added, so I am getting d by dt x1 of t plus d by dt x2 of t. And if I'll add this to particular signal and if I'll give to the system, so my now the input is x1 of t plus x2 of t, and both will get differentiate because the system is doing the differentiation only. So d x1 of t divided by dt plus d x2 of t divided by dt, both are same, means law of additivity pass. Similarly, check the law of homogeneity. So for checking the law of homogeneity, x1 of t system, you are getting dx1 of t by dt, you are multiplying k, so k d x1 of t by dt. Now you are first multiplying with k, so input is k x1 of t, then you are passing with the system, so this is your constant value, and if you will differentiate it, so you will get the same result, k dx1 of t by dt. So both are same, so law of additivity, law of homogeneity also passes. So differentiation is a linear function. Okay, so differentiation is a linear function. Same thing for integration, same thing for integration, same thing for integration. So for integration, if you will check it, minus infinite to t x of tau into d tau. So if you are providing the input x1 of t, so what it's doing, the system is simply integrate x of tau into d tau, right? X1 of tau into d tau. Again, if you will apply the x2 of t, so it will integrate minus infinite to t x2 of tau into d tau. If you will plus it, so you are getting minus infinite to t x1 of tau into d tau plus minus infinite to t x2 of tau into d tau. Okay, and if you are giving the adding it, and if you are giving the signal x1 of t plus x2 of t, so what it will simply, it will integrate from minus infinite to t. What is the input? X1 of t plus x2 of t. So t means t will be replaced by tau, because this is the property of the system, and d tau. So this can be separated in this form. So both are equal. Okay. And even if you will multiply it with some constant a, so a x1 of, at last a x1 k x1 of tau into d tau will come. And if you will multiply it with this also k, so the same result will come. So it's following the law of homogeneity also. So integrations and differentiations follow the law of homogeneity. Always remember. See, if any non-linear operator is there, then the system will be non-linear. So what is the non-linear operator? If any non-linear operator is functioning, then the directly you can say that system is non-linear. Example, the non-linear operator is, and how it will be, it is not like this x of sine t, this is linear. But if the function is like, yeah, wait, if the function is sine x of t, then it will be non-linear. Okay, so what is the non-linear operator? Sine, cos, tan, cot, sec, sine square, square, cube, okay, log, exponential. I will give you the example, don't worry. Modulus, sampling function, sync function, signum function, etc. These all are non-linear operator. Okay, sine, cos, tan, cot, sec, sine square, square function, cubic function, log, exponents, modulus, sampling, sync, signum. So how? See, so these operators, if it is, so note it down. So this operator we are using on operator either on x or y, input or output, then system will be non-linear. Some examples are there. Write out some example. The first example is y of t is equals to sine x of t. So this will be non-linear. Why so? y1 of t will give you sine x1 of t. Okay, and y2 of t will give you sine x2 of t. Both will be added. It will be sine x1 of t plus sine x2 of t. When you are giving the input, so this is your x1 of t input, this is your system, this is your x2 of t input, this is your system. When you are giving this all together as an input, x1 of t plus x2 of t, so the system, and passing with the system, so you are getting a y naught output as sine inside the input will come. So this is your input, so x1 of t plus x2 of t. So these two are not equal, so it is non-linear. So in the same way, if you are getting like this, y of t is equals to x of t the power 4, it is non-linear. If it is like that, t is square x of t, then it was linear. Okay, you can check it with this principle of a law of additivity. And the third example, y of t to log inside x of t is coming, then it is non-linear. And if it was x log t, then it was linear. Don't get confused. Okay, so, and if you are having the function like this, y of t mod of x of t, non-linear. Non-linear. Okay, fifth one, y of t, you are using a signum function on x of t, non-linear. Sixth one, y of t, you are using the step function u of x of t, inside x of t is coming, non-linear. Okay, seventh one, y of t, you are using sampling of x of t, it is also non-linear. Y of t, if you are using even function of x of t, so it is not linear, it is linear. This is linear. Okay, we had check x of plus t plus x of minus t divided by 2, so this was linear. And yeah, last one is, remember this one, y of t real function, so real of x of t, so this was non-linear. You will get x of t plus x conjugate of t divided by 2, so this will come non-linear. Yeah, like I am giving you a particular example for this. Suppose you have x1 of t input as a plus jb, right? So it's taking the real parts of system. What the system is doing, it's giving me the real part of x of t. So okay, real part of x of t is I'm getting a. Okay, I'm getting a. Now if I am taking another example, x2 of t, a c plus jd, so it will give me a real part of this, so I will get c. And if I'll add this two, so I will get a plus c plus j b plus d. And if I'll pass with the system, it will give me the real part of this. So real part is a plus c. This two, it will add a plus c. So it is coming. Okay. This is following. But if we'll check for additivity, homogeneity, so see this. We are passing the system. This is my x of t. This is a plus jb. This is a plus jb. A plus jb. I am getting y of t is equals to a. Now I am scaling this factor with j. I am scaling this factor with j. I am taking j, imaginary value. So j y of t will come. That is ja. Okay. Now what I am doing? I am doing scaling. First I am doing the scaling. So a plus jb. So if I'll do the scaling first, then I will get ja minus b. Now I will pass with the system, so I will get the real part, and real part is minus b. So these two are not equal. So the system is not following the law of homogeneity. So it's up to you what the things you are scaling. It's totally up to you. Okay, in any single case, if it is not satisfying, then the system will be nonlinear. So you have to find that single case. Okay, there are if you will take k here, if you will take the k here, then it will satisfy. But if you will take the imaginary part here, it is not satisfying. This was a tricky question. So okay, and the same thing is for conjugate antisymmetric. So if y of t is equals to conjugate antisymmetric signal, that is x of t, it can be written as x of t minus x conjugate of minus t divided by 2. This is the property of x conjugate of t. This is non-linear. Okay, so what is the note point? So from the note point you can say that if conjugate operator operates either on x or y, then system will be non-linear. Okay, then the system will be non-linear. Okay, can anyone tell me y is equals to mx plus c, is it linear or non-linear? If c is not equal to 0, is it linear or non-linear? If c is not equal to 0, I already told you, this is my input, this is independent. Whatever the things if you are putting, this is not dependent. No, it won't be a linear, but this is c, a constant value is coming.
Yeah, non-linear.
Non-linear will come. Yeah, non-linear. The system will be non-linear. So question number, yeah. This is your x of t. This is particular graph. This value is 10. This is y of t. So you are getting y of t is equals to mx of t plus 10. Okay, this system is non-linear. You can apply the rule additivity and homogeneity, you will see that it is non-linear. So by graphically we can say, if you are having a graph like this, then say this is linear or non-linear. You are having y of t is equals to mx of t. This is linear or non-linear. Here c is equals to 0. Linear.
Linear.
Linear. This is linear. And what about question number 3? If you are having a signal like this is your particular signal. This is y of t. So this signal is representation of what? Y of t is equals to mod of x of t. Okay, this is the mod signal.
Non-linear.
So mod signal is non-linear.
Non-linear.
Yeah, correct. Another question. Question number 4. If you are having the signal like this is 1, this is minus 1. This is y of t. This is linear or non-linear? Y of t is what? This is a signum function. Signum x of.
Non-linear.
So it is non-linear. Non-linear. So this was the concept of linearity and non-linearity. Any doubt, guys, in this? Till now, any doubt is there?
Yes.
Clear. Okay, fine. So practice these things by yourself, then only you will understand. So we had completed almost 125 pages. Now we will go for time variant and time invariant tomorrow. Then yeah, time variant and time invariant. Then invertible and non-invertible system is there. Yeah, a stable and unstable system. How we find the stability or unstability of the system. It's also a very important. Then LTI system, linear time invariant system. What you have? So you guys have studied DSP, digital signal processing.
Yes, sir. This some we have.
So these things I means sir has explained you these things in a class. This
Yes,
con
sir. But in brief, not this much depth.
in not in that much depth.
Yes, sir. Just
Just- So means
like a touch up.
okay, I understand. Means like from the upper layer they had explained something, not like
Yes.
that, not like that, right?
Yes.
So yeah, I can understand. Means studying the subjects in a college is very different, and for gates it's very different. Okay, so here you will know how to create the circuits. You will know how to make the signal. But if you'll study from that point of view, means in colleges and all, so you are going to mug up the things for creating the circuits and all also, right? So I can understand. So yeah, after that we'll study the transfer functions, LTI system. Then total response is there. Okay. Yeah. After this and all, convolution process is there. Mm, yeah. Condition of the LTI system unstable. I'm just checking when the Fourier series will start it for you guys. How much time it will take for Fourier series? Okay, fourth chapter. I think it will start. After three classes, three or two classes. Yeah, it will take three classes at least. Okay guys, good night. We'll meet tomorrow. Hope you
Yes.
enjoy
Thank.
the video.